Welcome to our session probability. Specifically, we'll be looking at what is called the normal distribution. The normal distribution. Now, the normal distribution is part of the probability distribution functions, except that this one has the following characteristics that we need to understand the concepts. So as you can see there, this normal distribution is bell-shaped. It is bell-shaped and it's asymmetrical about the mean, meaning the left is equal to the right quadrant. So the left side mirrors the right side. The other characteristic is that the area under this graph should always be equal to 1. And the tails never touch the base. So this is the normal distribution. Now, the examiner will be specific whenever they're dealing with normal distribution because they'll tell you that this follows a normal distribution. And before I go any further, I need to take you to what is called the Z distribution table here. The readings in this Z distribution table start from this far end to the last end. So the first thing you need to learn is how to read these normal distribution tables. So if you're given the reading of Z 1.2, 1.23. So we're starting 1.23 somewhere here. So you get the first two numbers here on the horizontal, on the Z value here, 1.2 and 0.03. This last number here should come from here, 0.03. Where they meet here, this is 0.8907. So what does that mean? It means that the probability from 0 to 1.23, so 1.23, this for error here is about 89%, 0.89, 0.07. So we're going to start with basics on how to read the Z table. Okay, so if you have Z is equal to 1.96, our reading will be as follows: under 1.9 and under 0.06 where they meet. So under 1.9 and 0.06. So let's go into the table and see the reading together. So let's go into the table and see the reading together. What is the reading under 1.96? So you go under what? 1.9 and 0.06. What is the reading here? What is the reading? 0.97. Excellent. So what does that mean? That the probability from here, 1.96, the probability, or this probability here, 0.9750. So meaning the reading from here to here is about 97.5%. Right. Now let me ask you a logical question. I've told you that each quadrant is 50%. If from here to here, this is 30%, what is the remainder from here to the beginning? 70%. 70%, yes. 70%. The total must add up to what?
100.
100. Excellent. I don't want to lose anyone so far. So the gentleman, let's go to the reading because it's very important. The gentleman, I want you to give me the reading for 2.33. And the ladies, I want you to give me the reading for 1.64. So the males, 2.33, the females, 1.64.
Who's starting, the males or the females?
Any,
The males.
the males. Yes, the males. What is the reading?
Okay, so the reading is for 2.33. So the reading is 0.9901.
Good. 0.9901. So this is called the Z, and the probability is 0.9901. Are you agreeing on the gents? Are you agreeing?
Yes.
All right. Then we also need to understand the opposite, 0.9901. If this is a probability, the opposite going backwards here is a Z. So if I ask you for the probability of 0.9901, what is a Z? It is 2.33. Sometimes you may not even be given the exact one. You'll be given 0.9900. This one is also the closest. It is still giving you 2.33. So I'll ask you, the gentlemen, before I go to the ladies. Now I'll start from inside. What is 0.9808? 0.9808. What is a Z for this probability? The gentlemen, so you need to look for it inside here. What is a Z for 0.9808? Quickly, ladies, help them. What is a Z for 0.9808?
2.07.
Okay, 0 point. It is here, right?
Yeah,
So 0 point what? What's the reading? It's
2
2.07.
0 7. Yeah,
2.0.
That is good.
06. 07.
no 7.
0.7. Now let me go to the ladies. What is the probability for the Z 1.64?
It's 0.9495.
Okay, let's
Yes,
check under
that's correct.
1.6 and 0.04. So
Yeah.
we get
Yeah.
0.9495. Do we agree?
Yes.
Yes, we do.
9495. Now do the opposite. Give me the reading for 0.9905. 0.9905. What is the Z for this probability? 9905. What is the Z? You
I'm
discover
trying to look at
Isn't it falling between
it is
2.34 and 2.35?
yes. So what do we do in that case?
It's falling in between.
It's falling in between. So you
Mhm.
pick the first one and add a 0.5 at the end. So instead of writing 2.334, instead of writing 2.35, you write 2.345. 2 point.
Okay.
So 2.34. Then you write a what? A 0.5 at the end. If it was lying between 7 and 8, would have written 2.375. So you choose the smallest one, then add a 0.5 there. Needless to say, the examiner will give you a point even if you're to choose the first one or the second one. They're not harsh on that, but I just want to ensure perfection. All right.
Mm.
I want you to be the best team. I want to take my time because it's a toughest topic. It carries more marks in the test. So I'm going to take you to the lesson now. We can start. So normal distribution, I've explained that each of the sides is what? 0.5. Then we have the formula for standardizing, which is Z is equal to X minus mu standard deviation over N. Or if you're not given standard deviation, it's simply X minus mu over standard deviation. Now, to read the following, I've already taught you how to read. How do we read 1.23? We go under 1.2 and 0.03 where they meet. 1.96, we've already done that. Then if you're given the probability, you go from inside the table. Let's try this one here. What is 0.8413? Read from inside the table. What is 0.8413? What is the reading for that quickly?
One 1.00.
That's correct, 1.00. .00. So now let's go to the lesson. So after finding this, we now need to learn how to read the Z table and to calculate the questions surrounding that. We've talked about the properties of the Z-score. They are symmetric about the mean. The area under graph is 1. The distribution is bell-shaped, and the tails don't touch the base. It is important. So now look, there are 4 steps important when you're doing the Z. Number 1, you need to learn how to illustrate. Number 2, shade. Number 3, standardize, and you apply. So to start with, greater than means shade to the right. Less than means shade to the left. So this table here is telling me 2 things. Number 1, it is telling me that the sign involved here is what? Greater than, because I'm shading to the right. Number 2, it's telling me that this shaded region is smaller than 50. So the answer I'm going is smaller than 50. So the answer I'm going to get, I'm going to subtract from 1 or 0.5, depending on the table I'm using. So for now, I'm using the full table. So the answer, if this is 30%, I'll subtract 0.3 from 1. Then this table here is also showing greater than because we're shading to the right. However, the shading crosses the middle line, meaning it's more than what? 50%. So we're going to read it directly from the table. And this one here is showing us that it's going to less than. And this one is also showing us the left side, it's going less than. However, this one is a small reading, so we're going to subtract from 1. This one is a big reading. We're going to simply read it directly. So we have a question here. Suppose the mean is 10 and the standard deviation is 3. What is the probability that X is greater than 16? So what you need to do, we are told that our mean is 10. We usually put the mean in between here. And our standard deviation is 3. We put it here, there. So X is greater than 16. So we're going to put our 16 here. So step 1, illustrate. We'll put a divider there. Step 2, shade. What determines where to shade is the sign. Here we're given greater than. So where there is 16, we're going to shade to the right because it says greater than. Then step 3, standardize. The formula for standardizing is x minus mu over standard deviation. So 16 minus 10 divided by 3. So 16 minus 10 is 6. When divided by 3, you get a 2. So what this means is this 16 is not there in the table. We need to convert it to a table reading in terms of Z. So these numbers are Z figures. So this 2 now, we read it in the table. 2.0. When you go into the table here, 2.0, you find it at it is 0.772. So what does that mean? It means the reading from here to here is 0.9772. So to get the reading which is remaining here, how do we get the shaded region? Since we know from here to here it's 1, so we're going to subtract 1 minus 0.772 to get 0.0228. Is that clear? Let me do that again. We are told that our mean is 10. Our standard deviation is 3. So we're being asked to find the probability of x is greater than 16. The ladies, step 1, what do we do according to the rules? Step 1,
Illustrate.
illustrate. In the middle here, we put our mean, which is a 10. Then identify the 16. Where is the 16? It's on the right side of 10. It's a 16. And we put our divider here. So where do we shade? The sign that is here. What does the sign say? Greater. So we're
Greater.
shading on the right side. Why? Because sign says greater. But already we know this is like a small shading. So the third step is to standardize. We can't read this from the table unless we standardize it. X is equal to Z is equal to X minus mean over standard deviation. So here we have what? 16 minus 10 over 3. We get 2. So we know that this is equivalent to 2. This is always 0 on the middle. So when we check in the table, what is the equivalent of 2? We'll go to the Z table. Equivalent to 2, we've already read that this is at 0.779772. So what does that mean? It means from here to there is 0.9772. So what remains there? X is greater than 16 will be equivalent to what? 1 minus 0.9772, which we got 0.0 0.0228. That is a reading. 0.028. So I now need you to lead us through this one here. Suppose x, we're being asked to find x is greater than 7. Who wants to lead us? Step 1.
Illustrate.
Illustrate.
Straight, good. What is here? We have a 10. And where's the 7?
The 7 is
On the left
The
of
left
the
side.
On the left side. So put 7 here. Okay, standardize it there. Then which side are we shading?
The right side.
The right side, because of the sign which is saying what?
Greater than.
So step 2 shade. Step 3,
Standardize.
standardize. How do we standardize? X minus mu over standard deviation. So our x is 7 minus 10 over 3. So meaning our z is equal to what? Negative 3 over 3 is
Mhm.
negative 1. So probability is never negative, but a z can be negative, to show you that we're on the left side of that. So we're going to read under 1 1.0. What is the reading under 1.0? 0 point what?
8413.
8413. So meaning, do we subtract or we read direct? Zero point 8413. So we read it direct because this shading is more than 50. It's about 84%. The reading from here to here can't be 84%. Obviously, it's meaning it's starting from this side, going this side. So whenever the shading is big, you read it direct. So this is about 84%. But the unshaded region is subtracted the difference from what? From 100. Now, sometimes the examiner can be funny. They'll ask you, find the value of x for which we are more by 2%. Find the value of x for which we are more by 2%. So whenever you're given a percentage, they're asking you to read from inside the table. So when you cut off this 2%, what we're remaining with is the what? 98%, isn't it? So 98%, they're training you to read from inside the table, what I'm just from teaching you. So let's go inside the table and find 0.9800. Which number is close? Which one is a Z for that probability? 0.9800. Which one is close? This one, right? Which one between the two? This one or this one?
The one on the left.
This one is less by 2, this one is more by 3 points. So this one is closer, isn't it? So what is this reading?
Yes.
2.05. 2.05. So meaning the Z at this point is 2.05. So when we do this, we now calculate, we know that Z is equal to what? X minus mean over standard deviation. So where there's Z here, we're going to put what? 2.05. Where there's X,
We're not supposed to add a 0.05.
sorry?
Didn't you tell us that we should be reading by adding a 0.05?
No, I said when you're reading the closest, if it's in between, but if it's the closer one, you pick it only, you can do 8.5 if it's the closest, if it's in between exactly. But in that case, it wasn't
Okay. Since
equidistant.
it's not okay.
Not equidistant. This one is more by 3, this one is less by 2. This one is close. All right. Are we together? So the Z, where is this 2.05 coming from? We first subtracted 2%, we remained with 98%. We read the 98% to give us a Z of 2.05. And X, we don't know. Our mean is 10. Our standard deviation is 3. And we calculate the value of X. This one by that one, we get X minus what? 10. This one by that one, multiply 2 times 2.05. So what are we getting?
Excuse me, not 3 times 2.05.
Yes, it's 3. Thank you. 3, yes. So what are we getting? Okay. Have you seen what I've just done? So just cross multiplied and we now go to another question. Suppose we are asked that find the value of x for which we are less by 28.1%. So less is on the left side here. Here, we're going to cut from this side, 28.1%. Can somebody tell me what we do? What we do after this?
We find that 28.8, what's remaining of 28.1?
Good. 20.1. What are we remaining with?
71.9.
71.9. 71.9%. So in decimal, what is 71.9? 0.7190. After this step, what do we do? We check it inside the table. We check
Yes.
it inside the table to find what number is either exactly or close to 0.7190. Okay, capture that number. Let's check inside here. We're looking for what?
7190.
0.7190. Is there a close one or an exact one?
Is an exact one.
Exact one. What is the Z for that one? This one here, right?
0.5.
0.5.
Good. 0.58. So since it's on the left side, our Z will be negative what? 0.58. What's the formula for Z? Z is equal to what? X
Mu
minus
minus
mu.
X minus.
and
minus
over.
So here where the Z, we're going to put 0.58
5.
negative. And our X, we don't know. Our mean is what? 10.
10.
And our standard deviation is what?
3.
3.
So let's find the value of X. We're going to have 3 negative 0.58 plus 10 is equal to X. So what do we get?
8.26.
6. Excellent. 8.26. So now I'll take you to the way he brings them in the exam. So I need you now to apply everything I've just taught you just now. So we're told that a soft drink vending machine is set to discharge an average of 215 mils of cool drink per cup. The amount is discharged normally distributed with a standard deviation of 10. So what are we given so far? What are we given? Number one,
The mean.
the
The
mean
mean
of what?
20 to 15.
215. What else?
The
Standard deviation.
Standard deviation.
What?
10.
10 ml.
10, good. So part one, if 225 ml cups are used, what proportion of cups overflow? So overflow is synonymous to which sign?
the right
Greater than
Good.
Better than.
Yes. So it's synonym of greater than. So step one, what do we do? Step one,
Illustrate.
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 What is in the middle?
10. 215.
215.
215.
And the standard deviation?
10.
10. Then part A, what is part A asking for? Probability of what? X is what?
215.
Greater than
215.
225.
225 means
Yeah.
So let's identify the 225. Where's the 225?
it's on the right.
On the right side of 215. Good. So here we put 225. Where are we going to shade?
On the right side.
On the right side, because the sign is what?
Greater than.
Greater than. So all right. So we're on step 2. Step 1, illustrate. Step 2, shade. Step 3,
Standardize.
standardize. So want to know what this 225 means in the set table. 225 minus 215 over what? Over 10. So what are we going to have?
10 over
1.
10.
10 over 10, which is what?
1.
1.
1, good. So when we check the reading for 1 in the table, what does it take us to? And now you should memorize 1. 1 should be at your fingertips. 0. What?
8413.
Yes. So 1.0 is 0.8413. So that's a reading from where? From here to there. 0.8413.
3.
So the shaded region there, do we read direct or we subtract from 1?
Directly.
Back from 1.
Subtract from 1
Oh,
because the shading is small. So 0.8413, when you subtract, what are we getting? Zero point
87.
1587. So you can leave it like that, or a proportion is a percentage. You can say 15.87% will overflow. Part B. What is the probability that a cup contains at least 200 ml of cold drink? What does the word at least mean?
Less than or equal.
That number and
Less
above
than or
or that
equal.
number and below? What does at least mean?
Equal or
That
less
number
than.
and above.
English is a prerequisite for this course, by the way. If you pass English,
That number and above.
yes,
That number and above.
So at most means that number and below. At least means that number and above.
Yeah.
We're being told at least 200. So where's the 200? On the left side.
On the left.
Which side are we shading?
I think we're still gonna shade the right side.
The right side.
Yeah.
Right? At least means greater. So what is the narration? X is greater than what? 200, right?
200. Yeah.
Step 1, illustrate. Step 2, shade. Step 3, standardize. So what are we going to standardize? X minus mu over standard deviation. So we're going to have 200 minus what? 215 over what? Over 10. What are we going to have? I said it will be 15 over 10,
Yes. Over 10.
which is negative 1.5. The negative just shows you that you're on the left side of what? Of 0. So at this point, we're going to read from the table. But before we read from the table, somebody tells me that there are principles that are there. You can tell from the shading whether we're going to subtract or we're going to redirect. What do we do here? The answer we're going to get. Are we reading direct or we're subtracting from one?
Reading.
Reading
Reading
direct.
direct.
We're reading direct because the shading is big. So
Yeah.
1.5, what is the reading for 1.5?
0.9332.
Yes, 0.9332. So 0.9332. Right? So this is 0.933. Now, the last part is what size of caps ought to be used if it's desirable that only
I have a question.
2% overflow. Yes? What's the question?
Didn't we say when we're told at least it's supposed to be greater than or equal to? So we're just supposed to
So greater than
not
or
use the sign.
greater, it's okay. Yeah, it's fine.
So it doesn't matter. You can just use greater than, not greater than or equal
Yes,
to.
it's okay.
Okay.
Yeah. At least 200. So starting
But
from
I haven't. So I haven't heard what are you saying? You can still use greater than or equal to.
actually precisely supposed to be greater or equal to. But in this case, we're dealing with adding the actual figure itself. So from what I've told you, it's one and the same thing, greater than 200 or starting from 200, you can put or equal to there. It will still be the same narration. So now when we go to part C, what size of caps ought to be used if we want to be 2%? If we're only desiring that we only lose out at 2%. So already, whenever I say percentage, you're being tempted to do what? To read from inside the table. Overflow is on the right side. We're going to first cut a 2% here. What is going to remain?
98%.
0.98. Okay. Here we have 215. We're being asked for the size of caps. So we're being asked for what? For the value of x. So we go and check in the table which number is equal to or close to 98% or 0.98. So when you go inside here, we already found 0.98 under 2.05. 2.05. So this 2.05 is our Z. So we're going to have x minus mean over standard deviation. So our x we don't know, and our mean is 215. Our standard deviation is 10. So I'll give you a minute to calculate the value of x. What is the value of x? Calculate. An insurance company has a portfolio of 10,000 policies. Whenever your sample size is more than 100, just know that we're using a binomial normal. You need to use a formula, which is mean is equal to n times p. And when we multiply npq, that is the variance. When you square root it, that is the standard deviation. In this case, we're told that an insurance company has 10,000 policies, for which it estimates a probability of 0.03. So this is already our P, meaning the remainder from 100 is a Q. So 1 minus 0.03 is 0.997. So this is our Q. Are we clear on these three important things? So after establishing that, we're being asked, what is the approximate probability of more than 40 claims? So to start with, we find our mean to approximate this in the binomial normal. So n times p, so we're going to get 30. So this is our mean, which is 30. That's how we got the 30. So the question is, what's the probability of more than 40? So x is greater than 40. We follow the 4 steps. Number 1, illustrate. We have illustrated. Standard deviation is here. And 40 is here. Then we're going to shade greater than. It's synonymous to more than. So we're shading here greater than, so to the right. And we standardize. What is this 40? So always leave the z in 2 decimal places because you can only read it in 2 decimal places. So if you have a number like 1.66666, make sure that you leave it to 1.67. That's how you read it from the table, because you need these two numbers. They're very important. So here, when we standardize, we get 1.83. So we check for this 1.83 from the table to find the actual corresponding reading. So when we went to the table, we found under 1.83 the following reading. 1.83, we got 0.9664. 0.9664. This means that the reading from here up to here is about 96%. So to remain with this other part, since the shading is small, we're going to subtract 1 minus 0.9664, which gave us 0.0336. This is how we find the probability that we have more than 40 claims. At this point, are we together?
Yes, we are.
Then part B, determine an approximate equal-tailed interval into which the question was not complete, into which, look at the last part, number of claims per year will fall with a probability of 0.95. So into which the number of claims per year will fall within 0.95. So 0.95 should be the in-between probability, so 95%. So if we're going to cut here and here, we have 95, so meaning we're going to remain with 2.5 this side and 2.5. So meaning we are looking for the values x1 here and x2 there. So what we're going to do now is to read from the table. When we cut off this one here, meaning from here up to here, from 100%, we're going to subtract the 2.5, which will give us 0.9750. So this 0.9750, we're going to check it from inside the table. So when we go inside the table, 0.9750, okay. Are you sure when we subtract 100% minus 2.5, what are we getting?
97.5.
97.5, which is this one here. So we'll go into the table and check under 0.9750 to find the reading corresponding to that. So when we go there, we found under 0.97, we found it at 1.96 exactly. This is the figure there. So meaning on the right side, we're going to get 0.976. So meaning that is our Z. Similarly, it's the same figure except that this one on this side should be negative because it's on the left side. So now we're going to calculate the values. We'll call this x1 and we'll call this x2. So when we use this formula, Z is equal to x minus mu over standard deviation. So here we're going to put 1.96 x2, then our mu is a 30 and our standard deviation is 5.469. When we cross multiply, we're finding our value of x2 as 40.72. And when we cross multiply this side, we're finding the value of x1 as 19.28. So this is a range. So after finding the range, that is the interval that the examiner is looking for. The next question that the examiner is asking is, we are told that in practice, 42 claims were received in a particular year. A director of the company claims that in practice, 42 claims were received in a particular year. A director of the company complains about the range of estimates in part B as being wrong. Comment on the director's complaint. So since we have established our range, we want to identify this as 42, whether it's within that range. Let's go and check. What was our range? 19 to what? To 40.72. So does the 42 lie within the range?
No.
So the director is right. Our comment will therefore be what? Yes, his claim is true. The range is wrong because 42 does not fall within the range that was found. So we are going to confidently verify the director's claim because the 42 is not inside here. 42 is outside. So yes, he's right because the 42 is not falling within this range we found here. Okay,